We will begin our discussion of quadratic equations by looking at the most basic way to solve a quadratic equation, and that is by factoring. So first, let's identify what a quadratic equation is. A quadratic equation in the variable x is any equation where we have ax squared plus bx plus c equals 0, and a is not going to be 0. Now, why do we call it quadratic if quad means 4? You think quadrilateral has 4 sides. So why do we talk about a quadratic equation if we have x squared as that defining characteristic? A square in Latin is called a quadratus, and so that idea of square and quad go together. So how do we solve a quadratic equation? Well, let's start with a warm-up. Let's imagine that we have 3 times a equals 0. What would a be? Well, we could divide both sides by 3, and that would yield a equals 0. Likewise, in part b, if we solve for b, we could divide both sides by 2, and that would yield for us b equals 0. But there's something more fundamental going on here, okay? So, if we think about each one of these, we have the product of two things equals 0. So the only way that a product can equal 0 is if one of the two things being multiplied equals 0. So if we have two things being multiplied and the product is 0, what can we say? Something times something equals 0. The only way that that product can be 0 is if one of these two is 0. So either a equals 0 or b equals 0, or both could be 0. We can formally write this as the zero product property. If the product of two quantities is 0, then one of the two things being multiplied has to be 0. At least one of the two things has to be 0. So if we look at an equation, we have two things being multiplied. We have 2x minus 1, and we have 3x plus 5. And notice their product is 0. So we have very much the same sort of construct that we have in our theorem. So one of those, at least, has to be 0. So 2x minus 1 equals 0, or 3x plus 5 equals 0. So this would mean if we add 1 to both sides, 2x would equal 1, x equals 1/2. Or if we come over here, 3x would equal negative 5, and x would equal negative 5/3. So this tells us that x equals 1/2 or negative 5/3. Now what's that mean? If we substitute 1/2 into our original equation for x, that'd be 2 times 1/2 minus 1 would be 1 minus 1. This would be 0 times something equals 0. That's true. So 1/2 is indeed a solution. Likewise, if we put negative 5/3 back into our original equation, this factor would be 0, and I'd have something times 0. And of course, that does satisfy the equation because 0 equals 0. So let's take a look at an example. Here we have a quadratic equation, and you'll notice that the right-hand side equals 0. So we do not have a product of two quantities equals 0, but we can indeed factor this left-hand side. So if you need to brush up on your factoring, it would be a good time to do so. So let's remember some of the things about factoring. First thing that we will do, we have this in descending order, and let's look for a GCF, the greatest common factor, between 12, 35, and 18, of which there is none. There is not a common factor that goes into each one of those three. So if this factors, it will factor into two binomials multiplied. Now, the last term is a positive 18, and that positive 18 is obtained by multiplying the last terms in the binomial, the last terms in the binomials. So, what will multiply to give a positive number? Well, they have to be the same sign. And you'll remember from your lessons in factoring that if they're the same sign, we look at the middle sign. So they'll both be negative. Now, 18 can be factored into 1 and 18, 2 and 9, or 3 and 6. Now, which one of those pairs is it? Well, we have no guarantees in this. So it's a matter of trial and error. Likewise, 12, x squared, well, the x squared will break up as x and x. Well, what about the 12? 1 and 12, 2 and 6, 3 and 4 are our options there. So through trial and error, maybe it would be a good time for you to pause the video and see what the factorization of 12x squared minus 35x plus 18 would be. So pause the video, try to factor the left-hand side, then restart the video and see what you obtain. Now what I'm going to do is I'm going to show you my process through thinking about how to factor. So I've already shown you that if we look at this last term and it's positive, the signs will be the same and they'll both be this middle sign. Now, how do we know which pair of factors for 12 and which factors of 18 will work? So what I typically do is I start with the closest factor. So let me try 3 and 4 and 3 and 6. So if we try 3 and 4 to factor the 12, and then we try 3 and 6, I can automatically know that this factor grouping will not work. If we try the 3 and the 6 there, I know it will not work. I don't even have to check, because the 3 and the 3 share a common factor, and there was no common factor here. In fact, 4 and 6 have a common factor. I cannot introduce a common factor that never was present. And if indeed we do check it, we just need to check our outer and inner terms. So we have negative 12x and negative 18x. That yields for us a middle term of negative 30x. So we know that's wrong. So let's go ahead and look now at another option. If we switch the 3 and the 6, we would have 3x minus 6 and 4x minus 3. And the same issue arises with this first binomial. We have a common factor of 3 that was not present in the original, so we know that won't work either. So those don't work, so we know it will not be those two. So let's go on to the next. So I'm going to stick with the 3 and the 4, and then we'll just run through these and see what happens. And then if none of those work, then I'll move on to the 2 and the 6, and then the 1 and the 12. There's no rhyme or reason to that. It's just process of elimination until we get there. It is trial and error. There's very little that you can do to make this speed up. So let's try 3x. We know that the signs will be negative. So let's try now the 2 and the 9. Let's see what happens. So minus 2 minus 9. So you'll notice that I have not introduced a common factor in here or in the second binomial. So let's check our smiles, the outer and the inner. So this would be negative 8x. This would be negative 27x. And notice that gives us our negative 35x. So if we FOIL this out, we would get 12x squared minus 35x plus 18. So this is our correct factorization. So now we can go ahead and solve. So 3x minus 2 would equal 0. Or 4x minus 9 would equal 0. So if we add 2, we have 3x equals 2, and x equals 2/3. If we add 9, we have 4x equals 9. So x equals 9/4. So therefore our answer is x equals 2/3 or 9/4. Now let's look at our next example. We have 3x squared minus x equals 0. Again, this is quadratic, and the right-hand side is equal to 0. So let's try to factor. Again, our first steps of factoring are it's in descending order, and then look to see if there's a greatest common factor. So between these two terms, we have an x that is common to both. So let's factor it out. So we are just applying the distributive property in reverse. So if we factor out an x, we get 3x minus 1 left. So notice if I distribute, I get 3x squared minus x. So now I have two things that are being multiplied. I have the x and the 3x minus 1. For their product to be 0, one of those has to be 0, at least. So x equals 0, or 3x minus 1 equals 0. So this would mean that 3x would equal 1, or x would equal 1/3. So our answer is x equals 0, or 1/3. Now, let's look at another example. Here we have 24x squared plus x equals 3. Now, I could factor the left-hand side, but the problem is that if we do that, let's just see what happens. I would have x times 24x plus 1 equals 3. Now, you'll remember that the zero product principle is that if I have a times b equals 0, one of them has to be 0, either a or b. Why does that not work here? I have two things being multiplied, but they're not multiplying to give 0. There are many, many ways I can get 3. So I can't say anything if it's equal to 3. So let's go ahead and subtract the 3 from both sides. So we can obtain 0 on one side and then begin to apply the zero product principle. So let's factor the left-hand side. There is no greatest common factor. Don't forget this is equal to 0. A lot of students will forget to rewrite that equals 0. So the signs here will be different because I'm multiplying to give a negative 3. So I should put plus, minus. Now there are only a few ways to get 3, and that's a positive 1 and a negative 3, or a negative 1 and a positive 3. So I'll try plus 1 minus 3. That could be wrong. Now, let's check 24x squared. So we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. We have lots of options for 24x squared. So if we try the 4 and the 6, 4x and 6x, I already know that this will not work because the 6 and the 3 share a common factor. So let's switch the 6 and the 4. So this gives you 4x. This gives you negative 18x, which does not give us positive x when we add them. That gives us negative 14x. So it's not that combination. So let's try another. Let's try the 3 and the 8. If we check the outer and the inner, we have 8x, we have negative 9x. That gives us negative x. We want positive x. So you'll notice that the sign that we have is opposite from the sign that we want. When that occurs, do you remember what we do? We switch the middle signs. So this will be negative and this will be a plus. And now it should be appropriate. Okay, so just to reiterate, this yields 3x minus 1, 8x plus 3 equals 0. We have a product of two things equals 0. That means that one of them at least is 0. So this means 3x minus 1 equals 0, or 8x plus 3 equals 0. So 3x equals 1 would mean that x equals 1/3. Here 8x would equal negative 3, so x would equal negative 3/8. So our answer is x equals positive 1/3 or negative 3/8.